So we just learned in our last section that we can write a ratio 3 different ways, with the 2, with the colon, and as a fraction. And we need to remember that these are really just fractions. A ratio is a fraction. So if it gives you like this, you can rewrite it as a fraction. And that's going to help us make some connections to what we're going to learn about in 5.2. So what we do to the numerator, we do to the denominator. So if we have 3/9, I'm taking 3/9. How do I get from 3 to 9? 3, 6, 9. I times that by 3. So in this box, right, we times by 3. So if I do that to the numerator, I also have to do that to the denominator. So if I need to times by 3 here, so 9 times 3 is 9, 18, 27. So these two fractions are equivalent. So what we do to the numerator, we do to the denominator. So we times by 3. So we times by 3. 9/27 is equivalent to 3/9. So we're going to be practicing making equivalent ratios and rates here. So make sure you have that top part filled out there. So an equivalent ratio is a ratio that names the same comparison, just with different numbers. So we just did one here, 3/9 and 9/27. Those are exactly the same. They're the same comparison. They are equivalent, right? Equal. You can hear that word equal, right? Equivalent in there. Okay, so sorry, I had a little mistake there. So we're going to double this here. We have 2, 6. We're going to times the numerator by 2 and the denominator by 2. We have to do the same thing to numerator and denominator to keep it equal. So 2 times 2 is 4. And then the denominator, 6 times 2 is 12. So 2/6 is the same thing as 4/12. They are equivalent. They're the same ratio, just it's doubled. So we can choose any number to multiply by as long as we do the same thing to the numerator and the same thing to that denominator. So those are equivalent ratios. We can also make basic ratios, and this is another word for a simplified ratio. So we know when we simplify, we want to divide by that GCF, that greatest common factor. So we have 2, 6, so same fraction here, but this time we're going to simplify it. And the GCF of 2 and 6 is 2. They can both be divided by 2. So 2 divided by 2 is 1, and 6 divided by 2 is 3. So we can see, right? So if we're making equivalent ratios, often we multiply, but we can, this is also an equivalent ratio. Lots of times we multiply, but you can also divide. A basic ratio has to divide. It has to be in its simplest form, the smallest numbers it can be, until it can only be divided by 1 to make that basic ratio. So basic ratio is simplified, and then an equivalent ratio is any ratio that is equal to each other. So let's try out some practice here. So we're going to go back to that basic ratio every time. Always come back to the basic. So we're going to look for a line where we know all the information. Oh, here we have flour and sugar. So let's circle that one so we know this is where we're starting. So we're trying to get back to the basics. So I'm asking myself, how do I get from 4 to 2? And you have to multiply or divide. So 4 divided by what is 2? So 4 divided by 2 is 2. And if I do it to the numerator, I have to do it to the denominator. So 6, right, divided by 2 is 3. So my basic ratio is 2 to 3. 2 and 3 can only be divided by 1. So this is our basic ratio. So now we're done with this one. We're always going to come back here. We're going to come back to that basic ratio. So I'm going to ask myself, so we know 12 here. So I'm going to ask, how do I get from 3 to 12? We had to times by 4. 3, 6, 9, 3, 6, 9, 12. So if I do that here, I have to do that here. So we're going to times by 4. So 2 times 4 is 8. So we're just making a bunch of equivalent ratios, but we're always going to come back to the beginning here. So now we have 18. So I'm going to ask, how do I get from 3 to 18? 3, 6, 9, 12, 15, 18. That was 6 times. So this is 6. If I do that here, I have to do that here. We're going to times this by 6. So 2 times 6 is 12. So we're not necessarily just skip counting, right? This is 2, 4, 8, 12. We didn't really skip count. We missed a few in there. So we're just making equivalent ratios. We're always coming back to this basic one. Now we have one on top. So we're going to say, how do I get from 2 to 20? Well, that was timesing by 10. So I want to times by 10 here. So 3 times 10 is 30. So all of these are equivalent. And this one right here at the beginning is our basic ratio. So I didn't want to come from always necessarily here to here, right? I don't know easily how to get from 12 to 18, but I do know from the basic ratio, all of these are just multiples of 2 and 3. So we're just making these charts, and really we could write these all as a fraction: 2 out of 3, 4 out of 6, 8 out of 12. So we're just making these fractions. We just put it in a table to make it a little quicker to write. All right, let's try one. We can also make tables that go up and down. Same thing. So we had 4 to 6. So here's where we're starting because that's the information we know. And we want to get back to this basic one at the top. So always go backwards first, then go forward. So how do I get from 4 to 2? Well, that was dividing by 2. So same thing, how do I get from 6 divided by 2? We make 3. So now we have this basic ratio again of 2 cups of flour to 3 cups of sugar. So we're trying to get from 3 to 9. How do I get from 3 to 9? 3, 6, 9. So on this one, we times by 3. So we'll do the same thing over here. 2 times 3 is 6. So 2/3, 4, 6, 6/9. These are all equivalent ratios. So now we have one over here. So we're going to ask, how do I get from 2 to 10? That's timesing by 5. So now 3 times 5 is 15. So all of these are equivalent ratios. The first one we want to put is our basic ratio that we simplified. So we go backwards, then forwards. So we can go across or up and down. It's the same process. So always go back to that basic ratio. Okay, we can also use our basic ratios to compare. So it's giving us this chart. So Wesley ran 12 miles and it took her 3 hours. Hayes ran 9 miles, it took him 6 hours. And Jude ran 8 miles, it took him 2 hours. So our chart's already filled out this time. And it wants to know who did equivalent running. So who was running the same speed as the other person, even though they didn't run the same distance, they may have been running the same speed. So we're going to simplify them. So we're going to think of their GCF. So factors of 3 are 1 and 3. So 12 can be divided by 3. So we're going to divide these both by 3. So 12 divided by 3 is 4. And 3 divided by 3 is 1. So Wesley was running 4 miles every hour. Now Hayes, we're going to list factors of 6. So 1 and 6, 2 and 3. 9 can't divide by 6, but it can divide by 3. We're going to divide those both by 3. 9 divided by 3 is 3. And 6 divided by 3 is 2. So we can see Wesley and Hayes were not running at the same rate. He was running slower. He didn't run as far and it took him 2 hours. So she was running like almost double his speed. So now we have 8 and 2. So we're going to list factors of 2, which are 1 and 2. And 8 can divide by 2. So 8 divided by 2 is 4. And 2 divided by 2 is 1. So I can see that Wesley and Jude were actually running at the same rate. She just did 1 more hour than he did, but they were both running 4 miles every hour. So we can make basic ratios, we can simplify them, we can multiply them. All we're doing is making equivalent ratios to be able to look and compare them. So go ahead and make sure that you've colored in any definitions, the numerators, the denominators, so anything that's going to help you remember this information.